Good morning, this is Alamon, and welcome back to Human Resource Machine, where we're going to start level 21. I don't know how many levels we're going to do per episode. I'm just going to do what I feel, I guess. Yes, we believe in educating our employees on the job here. Do you know what a zero-terminated string is? Yes, it's a very old technique, and we don't expect you to know, so you may ask me about it if you like, or you may ask an external source, whatever helps you get the job done. Alright, the inbox is filled with zero-terminated strings. What's that? Ask me your boss. Add together all the numbers in each string. When you reach the end of a string marked by a 0, put your sum in the outbox, reset and repeat for each string. That sounds pretty simple. So we know we're going to start by grabbing something from the inbox. We are summing them, right? Yeah. So let's jump if 0. Well, it's never going to start with a 0. Okay, so I can at least make that assumption. So let's get rid of the jump if 0 for the moment. So inbox, the first thing we need to do is copy to... I'm not sure why there's a 0 here. I'm not sure how that helps me. Well, the thing is, when we do the sum, what happens if we add from something blank? I don't know. So right now, what this will do, we'll take every number and add it together. So let's see if this actually works. Empty value, can't add with an empty tile. Okay, so how about... Oh, I know why we have the 0. So let's initialize the program by copying a 0 over here. Now here's our adding loop. And then eventually we'll jump all the way back out here. Okay, so here's our adding loop. If we get a 0, we want to copy from... So let me actually give this a name. That's the sum. Copy from the sum and deliver it to the outbox. And then we reinitialize the sum box to 0 and do it again. I think this might work. So initialize it to 0. Grab a 5. Okay, grab a 6, add them together. Now pick up the 0, deliver the sum. Reinitialize that to 0. Oh, lovely. Let's speed this up. There we go. I don't know if that's, like, literally the most efficient way to do it, but I'm pretty happy with that. Oh, hey, yeah, 10. Okay, that was a little faster than necessary. Alright. Go to Fibonacci Visitor. The back hallway is for advanced employees only. Are you sure you want to be here? Yes, I am. These night shift assignments are optional, you know, and they are difficult. If you need to ask for help, I'll just be here looking through these catalogs for a golden spiral. Golden spiral? What do you mean by that? For each thing in the inbox, send to the outbox the full Fibonacci sequence up to, but not exceeding, that value. For example, if inbox is 10, outbox should be 1, 1, 2, 3, 5, 8. Okay. So we're going to... call that, we need to initialize that as 1, I think, and then, our first number, our second number, so let's just say, first of all, let's bump... Yeah, I don't think I need that 1 over here. I think if I just bump this, we can get a 1, and then that can start our sequences off. This might be the wrong way to do it, but we'll see. So, we want to start our loop here. So, inbox... Let's call this target. This is the number that we're pulling out of the box. Copy to target. So we're not actually in our loop yet. So now when we start our Fibonacci sequence, we want to say... Well, okay, I'm at least kind of initializing here. I feel like I'm not doing this very efficiently, but so now we're going to start with the beginning of our Fibonacci sequence, and then I think we can kind of loop from there. So now what we need to do is this copy from might not be necessary in the end, but let's say our second number, copy from our second number, subtract the target. If it is negative, then we want to continue adding stuff. And that's where our loop's eventually going to go. I feel like we should be adding 1 number per round, and right now that's not what I'm doing. Maybe... So there's our first 1. It's already set. Okay. Maybe I should send... I am not going to win any awards for efficiency here. Alright, we've just brute forced the first 1. Now what we need to do is copy from first, add second, and now we somehow need to move the second number to the first place and paste down. Sorry, this is a little boring here, I think. I'm losing my train of thought. Copy from first, add the second, and I mean that's the next number, but we don't want to stick it in the outbox yet. We need to copy it to... maybe right now we'll call this result. And then we need to copy from result. No, sorry. Well, we will do that, but copy from second, first of all. Copy to first. Copy from result. Copy to second. I think this might work. Well, let's see what happens. Like I said, I'm going to have way more commands than I need. Can't copy to with empty hands. So actually, after we did the bump, that's when we should do this. Let's see if this works. Because then we pick that up. Outbox. So now we need to compare those. It's negative, which means we need to take another... What? Oh dear. No, I meant... The other way. If it is negative, we do want to do all the stuff. If it's not negative, then what do we do? Just jump to the end of the program? Whoops. Yeah, I see what I did wrong. Sorry, after we outbox that, we need to copy from before we can outbox again. Alright, we've started our sequence properly. So now we need to compare 19 and 1. And 1 is indeed smaller, so that means we need to do the next number in our sequence. Now we need to reset those numbers. Now we compare 2 and 19. Indeed, 2 is smaller, so now we add our Fibonacci things together. There we go. It looks like this is going to work, at least to add the sequence together. So let's speed it up a bit to get closer to 19. Alright, comparing 13 and 19. Okay. So now 21 is going to be bigger. Wait. I think I should be checking the result right before I send it, probably. Let's get rid of that jump. Let's get rid of that jump. Copy to result. Okay, copy to result. Subtract target. If it's negative, then do the outbox and all that stuff. If it's positive, then end the program. Okay, yes. Okay, what am I screwing up? Let me actually follow the debugging steps this time. Oh, that's what I meant to do. I think I just put those out of order. Okay. Compare those two. 3 is smaller than 6. Five is smaller than 6. Now we're going to have 8. Oh, because there's another number, of course. Stop and reset. So this jump should not be going to the end of everything. It should go to the inbox. Alright, so now let's see if it works. So we're going to compare 8. Is 8 bigger than 6? Yes, it is. Now our new target is 20. Oh no. We need to initialize again. Alright, let's see if this works. There's a more general way for me to do this, I'm realizing, but we'll survive. Oh, up to but not exceeding that value. I thought... Alright, it had to say less than. Oh, boy. Okay, well... Okay, I think I can hack this together. Oh, that is ugly. Oh, actually, if it's 0, no, this is still going to work. I was going to say, if it's 0, I could have short-circuited calculating the next number, but we'll live. I shouldn't have hit stop there. I want to see what's happening in my last step. So then we compare those. And then we're saying if it's negative, go down there. It's not negative. If it's 0, go down there. Otherwise, jump up here to copy from yada yada yada. Can I throw in another inbox command? Will that do anything? Like, if I say inbox and there's nothing in the inbox, will that end the program? I actually have no idea. Oh, no, because... Okay, let's do this. See if that changes anything. Okay, that was a good handoff. Now, the moment of truth is 8 bigger than 3? Yes, it is. Okay, so that is what really ends the program. That's not something I'd really considered before, but yes, if you say inbox and there's nothing in the inbox, that means you've done it. Oh! How about that? We actually had a really good result on the speed challenge. I definitely did not expect that. Okay, well, this worked. I think we'll leave that episode there. Good night, sleep tight, and don't let the bits bite. Bye-bye.